then they ask you to find the force in all members, in all of them, right? So when they say find the force in all members, usually the method of joint is better because it's more robust, systematic. We're gonna talk about the method of section soon, but you will realize that the method of joints is more systematic. You don't need to be creative. You just choose all the joints, write equation for all joints, and try to solve them somehow, right? So here, if I ask you, this truss is given, find the force in all members, and you only have 2 minutes, then it's kind of like, it's a big confusion. Well, if I write the joint, I have 16 joints, each one has 2 equations, so I have 32 equations to solve. How can I do it in 2 minutes? Right? But you got to be a little bit smarter. Say, I have this technology of zero force member that I can eliminate before I analyze my structure, so I can clean it up. So, where can I find my zero force members? Do you have any idea? So zero force members are either 2 members, 2 bars connected together, no external reaction, both of them zero, or 3 bars connected together, no external reaction, and 2 of them must be collinear. The third one is 0. Which one happens here? Or maybe both. Can you find it? Do I have zero force member here? Which one? 3. At joint 3?
All of the middle ones.
Exactly. That's the conclusion. We reached to that. So some people go super fast, and some students they don't know what's going on. I mean, we have always a big difference in the classes. I don't know why. Like the pattern we had in the midterm, it's always the case in beauty. Some students are super duper good, and some students are just super duper, you know,
sucky.
Yeah, I'm just. We don't have average. I'm just confused. Why? Like, why this is the case? I couldn't figure it out in these years that I've been teaching here. But as you can see, joint 3, right? Joint 3 is a good example of the second part. We have 3 bars connected together. No external reaction. Like if I have a force 2K here, I can't say this is zero force member. But look, joint 3 is free, no external reaction. 3 members connected together, and 2 of them are collinear. So the third one should be 0. Which one? This guy. The force in this member, 2, 3. So if the force is 0, I can clean it up. I can clean up the structure before, because if the force is 0, it has no effect here, right? You can just get rid of it. Force is 0. That is only put there for the purpose of the stability, like in a case that you have a force here. Because the structure you design, it should be robust. If you have a like arbitrary loading in bad scenario, worst case scenario, then it should resist. So these are extra bars put here for just the purpose of stability. But in this special case, you can just say this is 0, right? Am I done now? Yeah. Now you go to 2, P number 2, or joint 2.
So you're saying these bars are solely there for stability? They don't
Yeah.
help the structure whatsoever? Because you can take this and apply it to a bridge.
Yeah.
But those bars aren't there for stability, are they?
Yeah. So let's say you use it for a bridge, but let's say a bird come and sit here. Let's say a bird is flying, come and sit right here. This is the bird, right? There you go. If it sits here and you don't have this third force, this structure is going to collapse. So this just purely for stability remedies. If you are 100% that there is no external load, then you can just not put it there.
Okay.
But as I said, this is not the case. We always have external unpredictable loads that may be dangerous. So again, in this case, this is 0. Now, which one is the? Am I done, or I have extra zero force member? Which one is zero force member? 2. Pin number 2. Again, 2 members are collinear. The third one must be 0. Am I done? 5. Is there anyone that don't know what's going on here? I assume that you know. So this is 0. And again, 2 member collinear, no external load. The third one is 0. Let's say I have a force here. Let's say I have a load here. 5K. And here, for example. Then again, this is 0, right? 0, 0, 0, 0, because this is 0. But what about this pin here?
It has to stay.
Huh?
It has to stay.
It has to stay, because look, we have 3 members, but we have an external load here.
Yeah.
So we can't say this one is 0.
But if that one falls, then they all fall.
Huh?
If that one falls and that's the only pin that you have, then they all fall.
Yeah. That's actually exactly the proof that we use for that. So we're done here. But look, in the original problem, I didn't have. I just put this for educational purposes. I didn't have that. So again, this is 0, 0, 0, 0. So in fact, your structure has 3 members. You see it? Now you're ready to do method of joint. So this is the simplest truss you can ever get. You can't clean up any further, right? So now you go ahead and do method of joints. So you have joint 14, joint 16, and joint 1. And then you can find force in this member, which is this, which is this. You can take all this as one member. One member, one member. Yeah. You see that? Another thing, method of section. Now let's talk about method of section. Let's say you have a structure like this. Now, this example of crane. So it's a truss structure that is designed to take heavy loads and move them up without adding too much weight. So it's economic structure. So if your boss gives this structure to you and say, find the force in this member, let's call it member 1. Only this part, right? Not all of them. Then you say, well, I know the method of joints, and I know that the method of joints is pretty robust and it can solve everything. So if I apply method of joint, I can find it. Right? And I say, yes, you are right, and that's true. If you can use method of joint, then you can find it. But it would take a long, long time. So if you want to use method of joint, where should you start solving? Any idea? So you take all the joints, draw FVD, write the equation, solve. But you can start from here. How many unknowns do you have here?
2.
At this joint, here and here, right? So you write 2 equations, 2 unknowns, solve it, right? So let's check mark it. Let's check mark it. So you write the joint for that, equation for that, you solve it. And then what is your next joint to write the equation and solve it? Which one is your next joint? This or this?
Either.
No, if you write this, if you take this, 1, 2, 3 unknown. You see that? But how many unknowns do we have here?
2.
1, 2. So your next is here, right? So this is your joint 1. You start to solve it, and then you go to this one. Then you solve, you get which one? This one and this one, right? And then you go to this one, this pin or joint 3. How many unknowns do we have?
2.
1, 2. You see that? Then if you solve equation for joint 3, then you get this one and this one. Now which one is the next? The top, yeah, this one. So this one is 4. If you write joint equation, you already have this guy and this guy. So your unknown is only this and this. So you get this one and this one. And the next one is this joint, right? So you have these 2, you get these 2. So you can see that this procedure will work, and you eventually reach to this point number 1 and get the value and tell your boss, hey, I finally get it. Here, there it is, right? And then you get fired because it takes a day for you to do that. And your friends are, they're already done, they're finished. So then you get upset. What did I do wrong? Well, look, there are easier ways to do that. Any idea how we can just directly get this one here? I know that I can use method of joint to start with 1 at some point and start go marching all the way up to here. But it takes such a long time. I don't want to waste my time. How can I directly get the value of force in this member? Yeah. In fact, in the 5 steps, system, FPD, equation, 4, solve, 5, verify. In the method of join, we fixed step 1 to only joints. So here you get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 14, 15, 16, 17, 18, 19 joints. So 19 different systems and 19 different FEDs, 19 times 2 equations, right? But I say let's go back and take our system as a part of a structure, not our joints. Let's, in particular, as you said, let's just put, see that dashed line that we used to walk around in? Let's call it section. Let's section this structure here, imaginary cut, imaginary section, and just consider this part of the structure. Let's say this is my system, only this. Everything is external. Everything is external, right? Now draw system is a part, a section part of the truss. That's the reason we call this method of section, because your system is an imaginary cut part of the truss. Now, if I draw FED, what do I get? I have a 10K here, right? Let's put it this way. I have a 10K, right? Then walk around it. You have force here, F1. A force in this member, F2, and a force in this member, F3. That's the point you cut. right? There is going to be a force coming from this member. There is no moment because this is not beam. This is a thin bar, so it cannot go. You cannot have the bending moment, and you cannot have a shear load. You can have things like that. You remember we defined the truss. The force are only axial. So you have F1 here, F2 here, F3 here. Then continue walking, come back to the stop when you're done. This is FTD. Free body diagram, right? Everything inside this don't matter to you. This is interior. Just these 1, 2, 3 unknowns. How many equations do I have for this system? It's a 2D system. How many equations do I have? 3. How many unknowns do I have?
3.
So 3 equations, 3 unknowns. So you can immediately get these 2, 3. And then you don't get fired. Right? Now, let's do it a little bit faster. I know that I write summation of force in x0 for this system, summation of force is y0, and summation of moment about any point 0. Right? What point should I choose? How can I, if the point is just get F1, not F2 and 3, you're only F1, right? Then what's the fastest method to get F1?
Put it in for F2 and F3B.
Let's say I have this point, A, B, C, D, E, F, and G. What's the fastest method to get F1? I know that if I write all the equations, 3 equations, I have 3 unknown, I get F1, F2, F3. But I don't care about F2 and F3 for some reason. I'm only interested in F1. How can I get F1 with one shot?
Moment around D.
Moment around D. Right? Summation of moment around D. Why? Because F2 and F3 are going through D. So they don't show up in the moment equation. So if let's write this equation, summation of moment around D is equal to, let's start with F3. What do I get? Let's start with F3. What's the moment of F3? 0. F2?
0.
Plus 0. Plus F1? 1 times F1 positive or negative? Negative. And then, this is the external one. So what's the moment of 10K with respect to point B? 10K times, see, move it here. You see, this is the point. You see that? Move it here. So the distance is from here to all the way to D, which is 1, 2, 3, 4, 5, 6. Positive or negative?
Negative.
Is equal to 0. So F1 is equal to negative 68. You see, one line, one shot. You can immediately get it. This is called method of section. As you can see here, we did an imaginary cut. But for you guys that we started with 5 steps, you already know that this is nothing new. It's just a different choice of system. Okay?